PDCD4 is essential for T cells to activate AP1 polynomine.
In this video, I'm going to be talking about Urolithin A and ellagic acid from polyphenols and pomegranates, and how they have some surprising and tricky effects on cancer axes and immune effects and immune activity. Okay, so ellagic acid is found in pomegranates, berries, and nuts. Also, urolithin A is a gut microbiome derived metabolite of ellagic acid. So, urolithin A comes from ellagic acid. But not everyone can produce urolithin A efficiently. It depends on their gut microbial composition. So it's going to depend on what strains you have in your stomach. Okay, unfortunately, it has been shown that urolithin A and its polyphenols have been shown to upregulate CD39 and CD73, which is the adenosine axis. Now, if you've seen some of my other adenosine videos, you might already know. But basically, a quick recap is adenosine suppresses T cells. Okay, so this is actually context dependent because urolithin A would be good for someone who has autoimmunity, which in short would be T cells attacking the healthy body tissues. But urolithin A would not be good in a cancer patient, because the cancer patient needs the T cells to fight off cancer cells. But urolithin A, since it supports the CD39, CD73 axis, the adenosine would end up suppressing the T cells instead, unless if pomegranate is taken in combination with foods that increase the T cells. Okay, so the way Tregs upregulate or generate adenosine to suppress T cells to prevent autoimmune attack on healthy tissues, Tregs needs ATP to generate adenosine. So that's why tumors actually recruit Tregs, so that the Tregs suppress the T cells. Also, dying tumor cells, they also secrete ATP. So possibly so that the Tregs can make the adenosine to suppress T cells. But unfortunately, well, at least in cancer patients, pomegranates actually they support mitochondrial function in Tregs, because mitochondria provides ATP for the Tregs, so the Tregs will suppress the T cells. Okay, but on the flip side, a pomegranate could actually antagonize cancer cells. So maybe pomegranate and urolithin A are actually trying to keep the balance between Tregs so that the T cells don't attack the healthy body tissue, but at the same time, also pomegranates and urolithin A reduce cancer cells as well, and so that there is healthy body tissue without autoimmunity, and so that there are also reduced cancer cells. And pomegranate, as well as with oranges as well, does so by enhancing apoptosis in cancer cells. And the way pomegranates and oranges do that is by upregulating a tumor suppressor protein called PDCD4, and that's actually short for programmed cell death 4. Apoptosis happens to be programmed cell death. So another great impact on cancer that oranges and pomegranates have is that they suppress this activator protein called AP1, and suppressing its transcriptional activity. And it's often overactive in cancer and promotes proliferation and survival. So that could explain the high cancer rates, that this AP1 is not being suppressed. So possibly maybe cancer patients, they're not eating enough foods that suppress AP1. Okay, it has been shown um, that in cancer, low PDCD4 expression is linked in poor prognosis in many different types of cancers, such as breast, colon, and lung. Whereas upregulation of PDCD4, thanks to oranges and pomegranates and possibly other foods, induces apoptosis in cancer cells and inhibits the metastasis of cancer cells. Also, PDCD4 downregulates oncogenic proteins. Now, oncogenes are basically genes that support and upregulate cancer. Uh, so, by downregulating oncogenic proteins, PDCD4 sensitizes cells to apoptosis or programmed cell death. Okay, AP1 can also downregulate PDCD4, that way preventing apoptosis of the cancer cells. Okay, what cancer cells could do is that they could actually overexpress AP1 excessively, that it's way too much, that even if PDCD4 is present, that the PDCD4 is still not strong enough to induce apoptosis in cancer cells if the AP1 is too high. Okay, but it has been shown that oranges, with its compounds hesperidin, naringenin, and other flavonoids, can actually suppress AP1. Therefore, PDCD4 can induce apoptosis, but this has been shown in vitro. And pomegranates also have a similar effect, with ellagic acid, also has anthocyanins, um, can inhibit AP1 activity so that PDCD4 is not downregulated or suppressed by AP1. Okay, the proteasome degrades the PDCD4, inhibiting apoptosis in cancer. But there are the pathways that promote this degradation, and that is P13K, AKT, mTOR pathway, TGF beta pathway, also MAPK, ERK pathway. Okay, now some fruits that can help actually reduce or inhibit the P13K AKT pathway is oranges. So oranges reduces PDCD4 degradation. Next one is grapes, inhibits mTOR, similar to the first one, stabilizing PDCD4. Uh, Apples with quercetin can also inhibit P13K AKT, therefore reducing the PDCD4 ubiquitination. Ubiquitination is basically a part of the process of degrading PDCD4. Okay, now not all fruits are the same, but according to this data, that pears and polyphenols, that there is weak evidence for PDCD4 modulation. So it doesn't mean that pears aren't good. Pears, they do have other benefits. So the next one is mangoes also inhibits AKT mTOR, so stabilizing PDCD4. Okay, so quick recap. PDCD4 induces apoptosis in cancer cells. Pomegranate and oranges can upregulate PDCD4. If AP1 is too high, and it's common in many cancers, then PDCD4 will be suppressed and there will be no apoptosis for the cancer cells. The pomegranates seem to have a balancing effect with Tregs and T cells, so that T cells are not too high because Tregs steal IL-2 from T cells, but the pomegranate also induces apoptosis in cancer cells. Pomegranates are good for autoimmune patients if their T cells are too high, because the T cells will attack the tissues. But pomegranates would not be good for a cancer patient because they need their T cells to battle cancer. And the proteasome degrades the PDCD4, therefore reducing apoptosis in cancer cells. So that's it for the video. If you want more future videos, like, share, and comment. Keep it locked in here on my channel, and I'll see you in the next video.